Statistical Rethinking, second edition, chapter 15, and we're starting the medium questions. We're in the medium questions, 15M2. So here, this is the question. We're going to go back to the chapter for the data set. I think it's called milk. Yeah, milk. And we worked with this in part 15 or in section 15.2 earlier in the chapter. And there we were working on, we had some missing values for a variable that we called b, which was just a standardized, here it's not standardized, and I'll explain that in a second, but a standardized version of the neocortex proportion in different primates. So, but now, instead of standardizing this, we are meant to put a beta distribution on B. Okay. Now the reason this is important is because B has some missing values. Okay, and so when we generate these missing, imputed values for for the missing values, now we're going to use a beta distribution to constrain what is being proposed. Okay, and we're just supposed to run this. Okay. Okay. So one thing. So why are we using a beta distribution? Maybe we're free to use other things, maybe a uniform distribution or something, but because we want to bound B between 0 and 1, which makes sense because it's a proportion, right? We can't have more cortex than we have brain, right? So we have to bound it somehow. Okay. Let's kind of go through this. So the first thing I'm going to do is just generate my data. Okay, notice that B is no longer standardized. Okay, so because we're going to constrain it with a beta distribution, so here's my linear model, and now notice that B has a beta distribution, and I'm using the parameterization that's provided in the rethinking package, where I can give it a mean and a standard deviation. If you just use a beta, then you're using alpha and beta, and you have to derive the alpha and beta parameters to give you the mean and standard deviation that you want. And it's a kind of a hassle. So it's very convenient that we have this function at our disposal. Okay. But if you run this, you notice, and also notice that the priors are the same basically as what was done in the book. And when you run this, it doesn't run. Again, you get this error popping up, and nothing works. Okay. So these issues right here suggest that the imputed values that we're trying to put in there are not abiding by the boundaries of the beta distribution. Okay, so we need to set a prior then on the imputed values for B, and so that's what's going on with this line right here, right? So we're only proposing values between 0 and 1. And there's 12 missing values, which we found out, which we learned earlier in the chapter. You could just inspect the data to figure that out. The other thing that we'll do, and I don't know if this is a problem or not, but is that this coefficient, so remember, oh, in fact, I kind of played with that a little bit. Let me try that. That the beta coefficient then for B was, in the chapter model, was established for a standardized variable, right? And so so 99% of the observations should be within -3 and 3. Okay, but but now we're constraining the value of B to be between 0 and 1, right? So we've shrunk the possible values of B, which means we need to expand the possible values of the coefficient for B. Okay, so here I'm just going to use 3. And we'll just see if that takes care of it. So I'll pause this while this is running. Okay, so we're finished running here. And you can see that there's a little bit of difficulty early on in the chains, but pretty soon the sampler gets right on track. And we run without any errors, and when we check the R hat values, everything's 1. If we might want to check the chains and all of that, and you're free to do that, and I'm just not doing it here, I guess, out of laziness. But anyway, so when we made those modifications, right, again, let me recap what those modifications were. One is that we set a prior on the proposed values for B, right? And that came right out of this warning right here, right, which was informing us that, our imputed values were not, conforming to the 0, 1 constraints of the beta distribution. Okay. And the other thing that we did is we expanded the possible values for the coefficient of B. And again, the reason we did that is because we're now saying that B is between 0 and 1, whereas previously it could go from -3 to 3, right? So the range of possible values was shrunk, which means that in order to get, similar values for the product of the coefficient with B, we need to, if we made this one smaller, we'd have to make this one bigger, right? So, so we just expanded the possible values for the coefficient of B. Okay, and when we do that, we get nice mixing. Apparently, we should check the change and everything. I'm just not doing that for laziness, but all of that seems to work.